Good afternoon. I'm Molly Young from the Miami University Alumni Association, and today, as part of the Alumni Association's webinar series, we present Symbolic AI, Building Trustworthy and Explainable Systems. Joining us for today's webinar is Dr. Daniela Inclezan, Associate Professor of Computer Science and Software Engineering, and Dr. Jim Kuiper, Professor Emeritus from the College of Engineering. Welcome to both of you. Thank you for being here to share a little more about symbolic AI, what it means to the rest of us, and all of that other good stuff. A reminder to our viewers, you can submit questions during the live feed of the webinar by clicking the Ask a Question button under your video. So with that, I'm going to turn it over to the two of you, Daniela and Jim, to get us started. Welcome again. Thank you for being here.
Thank you, Molly. Let me just take a minute to introduce Dr. Inclezan to you. We hired her, was it 10 years ago now?
Daniela? Maybe 11, yeah.
And was one of the best hires we made. She's made such a difference at the university in the computer science and software engineering department. She's a wonderful teacher and a great example for our female students. And in fact, that's been one of her passions, to encourage the number of women in the field, which is an important endeavor. You may notice on her title, she's the Symbolic Professor, which is both an honor and gives her some extra resources to pursue her research interests. So she's a very well-respected professor at the university, and has, and another aspect of her interest that I want to mention is her interest in humanitarian engineering. So she's interested, I think, in, if I may speak for her, in using, developing ways of using computers to change the world in positive ways. And I think that's a wonderful goal. And now we want to talk some about a slightly different version of AI that she's been working on for quite a while. I do want to add one more thing that she has done, which is to start a study abroad program in the southern part of Italy that's been going now for 6 or 7 years, I think. Now you may say, well, what can you do about computer science in Italy? Why do you need to go there? We go there, we teach some computer science in the context, though, of another country. And in fact, it's not in one of the tourist sites. It's out in a beautiful part of Italy, the southern part, but it's a part where there's not a lot of English speakers. And so it's both a learning experience in terms of computer science for those students, but also a really big learning experience culturally for them. So thank you, Daniela, for starting that. And now tell us some more about, kind of set the context for where symbolic AI fits in machine learning and generative AI.
Yes, of course. And actually, to add a little bit about the study abroad program, actually, there are specialists in symbolic AI at that university, University of Calabria. And that's basically how the relationship started. And students go there and they learn about symbolic AI. So maybe I can start with some slides that I have prepared. And all of you have heard about AI. It's in the news. And I'm assuming, based on kind of where you are coming from, you may have heard different terms about what AI is. Maybe you, and I don't know if the slides have changed. Yes, okay. So in terms of AI, you may have heard about machine learning. Maybe you've heard about ChatGPT, large language models, generative AI, some of these terms for sure. And there's a simple picture right now in the slides showing kind of the nestedness of these components. However, the picture is not as simple, and artificial intelligence actually encompasses many more subfields. For example, if you think just about generative AI, that's part of deep learning. And there's also reinforcement learning, still part of the big bubble of machine learning. And then there are some other fields like natural language processing at the bottom of the picture, NLP, or computer vision. On the left-hand side, robotics, expert systems, knowledge representation. And still kind of the way artificial intelligence is organized into its subfields, not such a neat picture. We have a lot of overlap, techniques from one subfield brought into another subfield. So it's a complex picture, which makes sense because it's good to take methods that work and incorporate them into your research. My research, yes, go ahead.
So just to clarify, NLP is natural language processing. Explain a little more. What do we mean by natural language processing? Where does that occur?
For example, if you talk about large language models, that would be related to taking a look at the language that the prompt is written in, and then parsing that, figuring out also semantic relations. There are kind of lots of resources out there built by linguists, actually, computational linguists, about synonym sets and relationships between words. All of that at some level is brought into large language models, but natural language processing existed before large language models were available. And back then it was more taking a look at grammar, syntax of English, for example. How can the computer recognize the different components in a sentence, the semantic relations, the meaning relations between components? Another big problem in NLP was whenever we use pronouns like he, she, who does that refer to? For example, John saw Michael while he was walking on the beach. Who is he? Is it John? Is it Michael? Things like that. But large language models are more than just NLP. They also use reinforcement learning, and they have these big statistical methods and kind of complex machinery behind the scenes.
So the place that most people have seen NLP is something like Siri.
Yes.
We're trying to understand it. And I always like to think of the progress we've made as moving from kind of a syntactic analysis to try to move more to a semantic analysis. And I think the large language models have kind of started to move us in that direction. And your work really specifically tries to get at the semantic, the meaning behind, rather than just the syntax.
Yes. So symbolic methods, they are good at understanding, dealing with meaning, with semantics, not necessarily quite as good as finding out of co-occurrences of words, what words go together well, and these more statistical measures.
Mm-hmm.
And if you look at the picture, NLP is also part of image generators, because at least now we provide prompts in natural language, so they are useful. And there's kind of an overlap there, right, between large language models and image generators, not illustrated in the pictures because I didn't want to overcomplicate it. Yes.
I think most people know what ChatGPT is. Some may not know what DALL-E is.
DALL-E is a system that can produce pictures for you. I actually used it to produce the picture for this seminar, and you give prompts in natural language, and you have to refine your prompt, ask it to generate other pictures, more and more pictures, until you find one that you like. I noticed that it doesn't work very well if you want words to be part of the picture. The words are kind of scrambled. It's not a real word. Some of them characters are missing, and so on. And then pictures can vary quite wildly from one image that's generated to the next. But it can be helpful for things like this, for a seminar and so on, where you have an idea, you provide the prompt. There are a lot of decisions that have to be made by the human, though, in order to obtain what you want. So through the prompt.
It's that same issue of syntax versus semantics. The DALL-E isn't really understanding why the word should all be together because it doesn't understand the semantics behind.
Exactly. Yes.
But DALL-E is something that if someone wants to play with, they could. I mean, it's free, right? There's a free version.
Yes, there's a free version. Mm-hmm. And then there are other systems out there that can be used.
Yeah.
So in my research and what I will bring about is symbolic AI. Symbolic AI is used, for example, for expert systems, for knowledge representation, which will be the boxes on the left-hand side of this image. And symbolic AI has been around for a long time. It was very popular, especially in the 80s. So why bring it back in discussion nowadays? We have machine learning and then all these other subfields, deep learning and so on. Why do that? And that's because of some main limitations of machine learning. First of all, because it's a statistic-based method, it needs lots of data, large amounts of data. It's a data-hungry design, as we call it. The other thing is that the kind of AI that you see now that is has very good performance, you can be impressed by what it produces. So especially kind of going from deep learning and then large language models and so on, that is a black box design, meaning we don't know, not even researchers in those fields, the people who created those algorithms, they don't know how the parameters are set, how decisions are made to come out with a specific result, which means that it's difficult to intervene and make corrections if needed or ensure that the systems are fair. And I would like to go a little bit through the main limitations of machine learning just to justify the need to bring symbolic AI back into the picture and then explain how that could be done. So the need of large amounts of data for machine learning, that translates into resource intensive design. And what I refer to here in terms of resource is water and power. And there could be other implications, but these are the main ones. All the data that machine learning and especially deep learning, large language models use in order to be competitive has to be stored somewhere. And they are stored in data centers. Data centers just have lots of servers who store the data. This could be all the text we write, it could be pictures, videos, everything that's posted on the internet. And then a lot of that information has to be duplicated in case something happens with a data center. You want reliability, so it will be obtained from a different data center. And actually, this issue came about even earlier with social media, with all the pictures that we post on Facebook or whatever platform is used nowadays. All those things get stored somewhere. And servers get hot, they get heated. So there's a need to cool down these servers. And the technology that's in use nowadays uses water for that. A lot of water is being used just to cool down the servers in the data centers. But humans are also water. We are made out of water, 70%, right? So we have to think about how we prioritize the water usage, especially in terms of fresh water. And actually, a lot of data centers are built in areas that happen to be arid and rely on aquifers for their own communities. For example, you see the one in New Mexico, and that creates some kind of a conflict between the communities and the technology companies because of the resources that they need. For example, a story that was reported by Reuters, February of this year, in Chile, Google wanted to create a data center in an area where they were concerned about water scarcity. So the community fought to kind of make sure that all the environmental checks are in place for that. And kind of other than water usage, the power that is needed, first of all, for data centers and then to run the algorithms, that is also impressive in terms of the amount. Articles talk about, one on the left is from August of this year, about data centers increasing the risk for blackout and raising electric bills. Ireland, for example, has a lot of data centers, and it's expected that 30% of all power consumed in Ireland by 2026 will be related to data centers. And then here in the US, we should be concerned because actually 33% of the world's data center are here on US territory.
I was aware of
So,
the power consumption issue. The water consumption one I wasn't as aware of that. Makes sense. Another issue we need to be aware of.
yes, especially with how changes in patterns may happen. We have experienced a drier fall, for example, this year here. But in general, kind of being a resource that is so needed just for survival, how do we manage? How do we make decisions? And of course, I think from the media, you've seen this idea of reopening the 3 Mile Island nuclear plant, which experienced an accident in the late 70s, I believe, almost 80s. Yes. So there's this main issue to think about. And kind of these problems, environmental problems related specifically to large language models, they were brought into public attention actually in 2021 by a group of people, including Emily Bender. She is a computational linguist. And Timnit Gebru, she was the co-lead of the AI ethics team at Google. And you may have heard about controversies about how she left Google. And it's actually because of this paper. So they were talking about the environmental impact, basically in terms of consumption of power and water. And they also made a very good connection between the environmental impact and the social impact. They are always intertwined. If you think with any technology from the past, when it was implemented, usually it was implemented in areas that had lower resources, they were poorer and so on, highways when they were first constructed, maybe power plants and so on. So same thing happens here. They actually mentioned the case of the Maldives, which may experience the effect of the ocean waters rising and may not be a viable place to live in 100 years, yet because the language used in Maldives is a low resource language, some of these methods do not work for the Maldives. So they would pay a price, but they would not necessarily benefit from large language models. And this is called environmental justice, kind of reacting to that is something that they brought about.
Could you explain that title, Stochastic Parrots?
Stochastic parrots would refer to the methods that are used in large language models, kind of these statistical methods. Parrots, because large language models use large volumes of human-generated text scraped from the internet, and they kind of reproduce the same patterns, but they look at the whole amount of data coming from different people that contributed to what is now on the internet in terms of text.
So let me make sure I understand the issue with the Maldives. So people want to use their resources to do the large language models for us, but to do it for them, their language, there isn't going to be enough data for them to get the same advantage in their language that we get in ours. Is that?
Yes, however, the environmental impact, it's actually more of a chain in the sense that on the Maldives themselves, I don't believe there are data centers. They are here. However, since it's an interconnected world, yes, yeah. And we've seen kind of effects, long distance effects when there were wildfires in Canada, we got the smoke. So kind of same idea, but on a larger scale. Yes. The only thing is that island nations would be impacted first if the ocean waters rise, right? So,
but you actually, it's an interesting justice point that I hadn't thought of, which is that, I mean, there's a whole lot of English spoken, written that we can exploit to learn, to make our models work for us. And there's probably a good amount of French and Spanish, but there are a lot of other languages for which the large language model may not be as good, just because there isn't. It takes a huge amount of data for these large language models to work. We mean really large. We don't mean large. We mean immensely large. So it's an interesting point I hadn't thought of before.
Yes. And we've experienced that. I've been collaborating with the Miami Center for the past year and a half, and I'm learning a lot about that. So for those who don't know, Miami University was built on the lands that originally belonged to the Miami tribe. And we have a Miami Center who works on revitalizing the language. The language has suffered historically with the boarding schools and so on. People in the community were not allowed to speak the language. There is some linguistic data. It actually comes from Jesuit manuscripts. Sometimes there's the Miami word or sentences and then French or English translations. So there are ways to recover the language, but the data is not abundant, not as abundant as for large language models to be used. And then I also like how cautious and careful they are about what happens to their data, their language data. For example, they are very cautious of having a third party handle it to create a large language model for them. And also there is this idea that the community itself should be in charge of what happens to their own language data, given that in the past, in the history, kind of the colonizers already abused and did not allow the language to be spoken. So it's a different perspective on language compared to English or even Romanian. I'm from Romania originally, that we need to respect the cultural differences and different perspectives. Should I move along?
Oh, please, yes.
The other idea, so we talked about how resource intensive machine learning is, especially deep learning and large language models. And I hear a lot, especially from the technical community, saying that people saying that, well, there will be progress, right? So there will be, algorithms will be more efficient. We will need less data in the future. Yes, possibly. However, improving efficiency, if you look historically at other technologies, doesn't mean that overall, looking at the whole world, there will be a reduction in the use of a specific resource like water or power that we talked about. This picture on the left is about cars. And one of the people here says, these new cars are so efficient, everyone's driving everywhere these days. Just as cars became more efficient, or even electricity in the houses and so on, we are using more of it overall because the price has gone down, it's easier to use them. And this is Jevon's paradox. And I like to remind myself about it in many occasions as we talk about any kind of technology, but AI has a big impact right now. So bringing it back to the AI. And that relates to two mindsets that I think we need to be aware of, especially in computer science, maybe engineering as well, because we are problem solvers. We want to solve problems. That's what we do best. But there's a tendency towards techno-optimism, which is the belief that future technology can solve current socio-ecological problems. So this idea that, okay, maybe now the technology is not at the best, but it will become more efficient. Why should we be aware of it? Kind of going back to the previous slide about efficiency, we can improve efficiency, but overall, won't we still increase consumption? So just this idea of maybe being a little bit more wise about what we do, not just smarter, but also a little more wise in terms of how we use our resources, because we live on a finite planet and we don't know what's on Mars, but if we cannot take care of this planet, I don't know, yes, what we can do, even if we discover things on another one. The other mindset that I think we should be aware of is technosolutionism. This is the belief that technology can be used to solve social, political, environmental problems, often to the exclusion of other approaches. So the problem here is that there may be some issue that is just a social problem. It could be solved with a social approach. But if we tend to think of technical solutions, then maybe we overuse technology. Maybe we overuse AI when it's not appropriate. And I think it's very important at this point to figure out when do we need to use AI, and even within AI, when do we need to use machine learning or large language models, when it's not appropriate to use generative AI. And that kind of relates to one of the courses I'm teaching right now, which is comparative programming languages. We see a lot of programming languages, the features they have, but one of the main goals of the course is for students to understand when it's appropriate to use one of them versus the other. What are the benefits? And make decisions based on what's the best application domain.
In fact, let me interrupt you here just a minute to
Yeah.
say, I have taught that course before, and I didn't think of it in that way. I didn't do that, and I should have. This is one of the reasons I think hiring you was excellent for the university. You're kind of bringing in some of these other thoughts that just hadn't occurred to many of us in technology. We think about technology, and you're not opposed to technology, so that's not the point. Yeah. You're just, I think the term wisdom is an excellent idea that we need to bring in wisdom in our use of technology.
Yes, yeah, and maybe a little more cautious behavior. Yes, yes.
You know, it just reminds me of something. This isn't nearly as important as what you're talking about, but it reminds me of going into McDonald's nowadays, and you're supposed to go to the kiosk, and I miss talking to people sometimes. I think, is the technology solution better there? Maybe it improves their bottom line. I'm not sure that it's the right experience that I would want, but and I don't mean to say that that's very important. It's not, but it is that kind of that idea that the technology is the solution when it's not always the solution.
Yes, yes. And I would like to mention that I do have an interdisciplinary background. In my bachelor's, I also studied archaeology. I did a master's in second language acquisition. So I do have broad interests, and that's where this is coming from. And I think especially at Miami, being a liberal arts college, it's very important to reach across the disciplines, social sciences, humanities, the arts, and that's what we strive towards with our students, I would say. So I'll move on to the next slide. I mentioned that a lot of data is needed in machine learning. Not just the quantity of the data is important, but also the quality. And if you need a lot of data, making sure that you curate it and you check the quality is a little bit harder. It's not always possible. That can have an impact on accuracy, especially in some sensitive domains like medical diagnosis, legal reasoning. The question there would be, what kind of accuracy is good enough? How many false positives or false negatives in medical diagnosis would we as humans accept from AI? Maybe it's different if it's a doctor, a real doctor, but from AI, what is our acceptance level? And this kind of ties in also with the same paper that I mentioned before. They also talk about how size does not guarantee diversity. Meaning, if you get a lot of data, let's say from the internet, it doesn't necessarily represent everybody, because there are people who do not contribute to the internet because they do not have the means or because they choose not to. And also, the other idea is that the data that is being scraped and is informing, let's say, large language models. This is static data. It's data from the past. And how quickly can it reflect changing social views and so on? That's the other question.
Yeah, I know that one of the criticisms I heard of ChatGPT, one of the earlier versions, was that the data was, and I forget the date, but it was collected up to like
2020 or something.
2020 or something. So if you ask about current things, it just wouldn't be aware of that. Not all the tools have that particular problem, but it is an issue.
Especially nowadays, I think they improved with that, but still you are always relating to data from the past. And if you want to construct a different, I don't know, a different community, different norms that you want to respect as a group, right? It's harder because the past is going to condition you. Lastly, I didn't mention the black box design. This is a problem, especially for deep learning. There are, I put a picture here on the left-hand side, how deep neural networks look. There are lots of hidden layers, lots of parameters in large language models, even billions of parameters. And the problem is that the researchers in the field cannot understand how those parameters are set, what is important for a model, what it picks up from the input, and so on. So actually, an initiative that started in 2016, it's a DARPA initiative towards explainable AI, is very important right now in the machine learning community. They are working a lot. This is about how to make human users understand, appropriately trust, and effectively manage AI. But there has been little progress to date, especially because explanations, if we look at what humans would expect in terms of explanations, they are almost kind of cause and effect. So we expect something in terms of causality, probably. However, these machines are based on statistical methods. They don't use causality. They use other means, and therefore it's hard to implement explainability in there.
Yeah, before you go on, let's talk a little bit about this picture. So on the left side, the blue are the inputs that are understandable to humans. On the right are the outputs that probably are understandable to the humans. In between, and you've shown, 3 layers with 5 in a layer. The real models may have many more layers and it's much more complicated than this. And then you have those connections between them. And the way the learning works is those connections are labeled with weights, numbers. And so they vary those and then run it thousands, millions of times. And finally, they find some combination of, 10% here, 5% here, whatever, and out pops something that works well. But when you start looking inside these connections, the semantics behind it, why that works is just kind of mysterious, because the middle layers don't have any meaning to them to us. They just are choices made kind of randomly, stochastically. So I think what you mentioned there is really a huge problem. How do you know the answer is right when you use a large language model? Now, in some cases, it's obvious, but how do you know? And how would you know, any other reasoning is right? Well, you follow through the processing, and we understand, if this is true, then this is true, okay. And if that's true, then that's true. You can understand the reasoning. And you say, okay, I agree with the conclusion, because not only do I understand the inputs, I understand all the decisions made in between that got me to that conclusion. Here, we don't have any. It works is the reason we trust it. So it needs a lot more work. And your work, symbolic AI and combinations, as we'll see here later on, are part of the solution to that.
With something like what's on the slide, we don't know when it will fail. They are not guaranteed to be 100% correct. And then in terms of safety, if you think about accidents that have happened in aviation and so on, you could look back at the code. That it was just programming code, not necessarily AI. You could look back at the code and see where the error was made and change it. Here, you don't know what's going on. As an expert, you cannot intervene because this is so complex that it's just, and it's not in human terms.
Yeah.
So moving on to symbolic AI, again, I mentioned that there was a lot of hype about it in the 80s. Now there's kind of a 180-degree switch to machine learning, but I think diversity in terms of techniques that are being used is actually good. So why not combine the two instead of having either one or the other? Symbolic AI uses human-readable symbols, as you will see next, and it uses logic. So the programs are provably correct mathematically. It uses rules of the type if-then, and that allows you to construct more knowledge, infer more things out of the base things that you have. And I put that on the left-hand side of the next slide. To contrast machine learning, what it does, it learns patterns from large amounts of data. And to do that, it uses statistical methods. So as a little example, I want to show you how that may look like. It's a short program. Let's assume we are representing what we know about a family where there's some people, Alex, Sam, Bobby, and Blake. And then we talk about the genders of the people in the family. And we know some mother-father relationships that we state, where the parent is the first item and the next item in this lines of code on the left-hand side on the bottom, those would be the children. Person, gender, mother, father, those are choices that the programmer, the human who writes the code, will make. And it's visible just by looking at the code that some assumptions were made by the programmer. For example, we see only 2 genders. That can be corrected. If we want to add something else, we can add, for example, gender non-conforming, or whatever decision we make, that can be addressed. Also, what's on the left-hand side, those would be facts input. It's not something that the AI has done or has learned. On the right-hand side, you have rules, general rules. We call them general because we use what are called variables, X and Y, just like in logic. And there's a special symbol in the middle, the colon dash, that is read as if. So the way you could read these rules, a parent, X is a parent of Y if X is a mother of Y, and the same for father. Again, there could be assumptions here. Looking at other rules in the program, does it talk about traditional families, or does it also include non-traditional families? You could see that in the code, address it as needed.
In other words, you could add stuff about stepfathers and stepmothers and just all kind of combinations. It makes the whole thing more complicated, but it turns out the real world is complicated, so you shouldn't expect it to be simple.
Exactly. Yes. Yeah. Yes. Same if you think about, so you mentioned a little bit introspection. It's always very complex, especially as we think about common sense knowledge, or even knowledge that is culturally based. It's going to be complicated to put that on paper, a little bit complicated. For example, we want to say X is a brother of Y. What do we need to do for that? First of all, X has to be male because X is the brother. Otherwise, we would use sibling, sister, or other terms. And then do we ask for just one parent to be in common, both parents? What is the situation here? You can take a look at the rule. The rule, you can interpret it. It seems that one parent has to be in common because we see P, parent P of X, parent P of Y. However, the rule is actually not complete. And that illustrates how we take many things for granted. And it's a little bit difficult in symbolic AI to think about all of these things. X and Y have to be different. Otherwise, you will be your own brother. What else? Also cultural information. When I teach this in class, if I have students from other areas and we work with the relationship ancestor, they always ask me, does it include great aunts, great uncles, or is it just an up the chain parent, grandparent, great grandparent, and so on? So that's a choice that you make, but you can see it then in the rules that are being shown.
So back to my
yes.
point about syntax versus semantics. You're now kind of trying to put the semantic, that is, you're explaining to the program what the meaning of brother is. You've got exactly. Not just a syntactic thing here, it's trying to introduce the semantics into it and capture that.
Exactly, yes.
And doing it in an understandable way also. I mean, there is some syntax to this language that you have to get used to, the colon dash, but
yes.
But once you've got that simple syntax, the meaning is pretty clear.
Mm-hmm. So sometimes, depending on how complex the program is, you would need a little more training, but then an expert would be able to look through this, whereas with deep learning, not even experts can understand why the model is the way it is. And if the program is too big, even in the case of symbolic AI, there are ways to create graphs that explain how the inferences were obtained. For example, at the bottom, you see brother Bobby Blake. Bobby is a brother of Blake. Where is that coming from? It's coming from some things that were given as a fact. Those would be the gray boxes, plus some things that were inferred, that Sam is a parent both for Bobby and Blake. These graphs are meant basically for researchers still. If you want to produce an explanation for a general audience, then humans would not like to see the whole graph, but basically just the relevant information. So we should look at the social sciences, psychology, humanities to see what humans expect in terms of an explanation. And Jim has mentioned syntax before, so even symbolic AI has some difficulties. This is part of a program for an agent, let's say a robot, maybe a self-driving car, something like that, that would be able to navigate in its own environment. What would it need to know about the environment, about its own speed, location, and so on? And on the right-hand side, how would it plan the actions that it would take to get to a specific destination, for example? So you see that syntax is becoming more complex than in the previous example, but that's kind of all I wanted to illustrate here. And kind of going back to the comparison between symbolic AI and machine learning, symbolic AI needs only small data sets because it actually uses expert knowledge. That is, if we deal with particular domains, otherwise just human knowledge in general, common sense knowledge. On the other side, machine learning needs large data sets because what it does is pattern discovery. Symbolic AI is transparent and explainable. Machine learning is opaque because of the black box design. However, symbolic AI on the left-hand side, it does need introspection. And it also needs, as a human, you need to spell out everything that you even take for granted for the machine. So the bottleneck in that case is the knowledge acquisition bottleneck. Machine language is scalable. It can deal with a lot of tasks just by looking at large data sets. However, the drawback at the bottom, that's it's resource hungry. We talked about massive amounts of data and then water and power. So that's why one idea is to take advantage of the two. Some ideas come from mimic human behavior. It seems like kids learn patterns from what they see, but then at some point as adults, we don't need to experience everything and we can learn just from somebody telling us something. So basically from definitions or somebody else's experience. I don't know how much we actually know about how humans learn, so there are some limitations, but in the same grain, why not take advantage of the two methods in order to use smaller data sets, so be less resource intensive, kind of address the drawbacks from machine learning. And I'll just mention a couple of ideas that are out there. There are some examples of how that's done in some of the recent papers I've read. One of them is to use large language models to extract information from natural language text, for example, math problems, or a chatbot interacting with a human user that wants recommendations. Then once you have that, kind of extract this natural language, the facts, just like the facts in the knowledge base about the family, then on top of that, use general rules, logic programming rules to actually reason and do the heavy lifting, think about the semantics and so on. And once you have a result coming out of the symbolic AI, out of the logic programming, the output is very mathematical. So then translate it back using large language models back to natural language for the users. That's one approach. The other approach is to use machine learning, but instead of learning a model that maybe just parameters with different settings, what you are learning is logic rules. So the output would be a logic program, basically. For that, you would have to provide relationships of interest and positive and negative examples. For example, work has been done with loan applications. Some relationships of interest with me may be the gender of the people, their income, and other information. And then whether they got the result or they got the loan or not, together with all the other information related to that person, could be positive or negative examples. And then machine learning will extract logic rules. For example, if you have this gender and certain income, you will get the loan. If you have this gender and maybe some other feature, you will not, something like that. And I can go more kind of talking about these examples, but I think it would be good to stop with the presentation and allow time for questions. What do you think, Jim?
Yeah, sure. And I see there are a few questions that people have typed in, and please, if you have others, please send them in. Let's take this one, Daniela. The first question there is about the AI outlook and application in liberal arts, say in writing and marketing, business. What do you see there? And in particular, do you have any examples of people using ChatGPT or something in your classes, either in ways you encourage or in ways you discourage?
Maybe I'll start about the classes. There are different tools out there. Copilot is one of them that assists you with learning how to code. Assist you with coding, I should say. The only thing is, in the basic introductory programming courses, I would not recommend students using AI to help them code because they still don't know when the output is correct versus not. And AI is not 100% correct. So you need to build your own understanding to be able to check the result. Otherwise, the only thing you can do is through testing, but testing can never be comprehensive, at least not in real life applications. So maybe there's a place later on in the upper classes, computer science classes, for using AI assistance, but in the lower, for coding, in the lower level courses, I don't think it's productive. I've heard from some of my graduates that it is used to be more efficient. Again, the idea of efficiency and productivity in the business. So maybe we should kind of teach our students how to collaborate with AI. However, the human has to be in the loop at all times to ensure that. Business was one of them. I've participated in some seminars by OpenAI on ChatGPT, and they talk a lot about how to use it for business. In one of them, they showed how you can analyze your data, but they always stressed human in the loop, kind of checking. And then my question was, well, if you still have to check, then why not just use Excel where you set up your own formulas and you know that everything is correct instead of having to check. And the problem with large language models is that they are correct a lot of the time. So it's very hard to find mistakes if they are there and to know when to trust versus not.
Let me pose a potential ethical issue to you. Something I did, and you tell me if I was wrong to have done it. A semester ago, maybe it was in the spring, anyway, a student that graduated asked me for a recommendation. He wanted to go to grad school, and he's a good student. I was pleased to write the recommendation. I wrote, I think, a strong recommendation for him. And then I submitted it to ChatGPT and asked them to revise it. And it came out so much better. Is that still my recommendation? Ethically, was I all right there? I mean, it didn't add anything to it. Everything it wrote was what I had said, just it said it in a different way. What do you think?
Yeah, I don't know what to say. As a non-native speaker of English, I do that as well, in the sense that I like to write my own thoughts. However, that's very choppy language, and I ask ChatGPT to refine it, and then I go back again and change things that it did not get accurately, or set my tone, stress some things. But especially if you don't have strong communication skills or you're a non-native speaker, it does help. Now, what does it help us do? Be more productive, right? More efficient. So it's again, doing things faster. It's very helpful in the workplace, but we should also pay attention to kind of as humans, what are our goals? Does it improve our happiness? Not lose track of that. But I do say, yes, I admit it does refine very well and it helps. I was mentioning to you before, or to Molly, as a non-native speaker of English, ChatGPT helps me a lot in writing. However, when I speak, it's still me, right? Talking the way I speak and then making grammar mistakes and so on. So I think it would be a nice research project to see if you really are the human in the loop and you not just copy what ChatGPT produces, but you write first, you revise what ChatGPT has produced. At some point, are you getting better at kind of assimilating English expressions and writing in a better, and also in speaking, not just, so when you don't have ChatGPT with you? That would be one. But I think also these large language models tend to be very general usually, and you have to make a lot of prompts, decisions in order to make it very tailored to you or to a specific style that you want.
You keep using the term the human in the loop. And so I'm reading a question here that I think gets at that also. And so the question is this: isn't one advantage of symbolic AI that it's limited to what we know? The models for games like chess and Go identified new approaches that no human could ever come up with. So what do if you
yes, so that does relate also with this knowledge acquisition bottleneck, that kind of the main issue. Also, even with common sense knowledge, there are disagreements based on different views or cultural differences of what is the knowledge, and maybe that's just appropriate for one domain. So yes, I would say it is limited to what we know, and that may be a place where we decide symbolic AI is good for expert systems, not so good for other things. So it's good when you know and you have the knowledge and you want to encode it, not so good at discovering patterns. Yes.
But the other side of that is it's much better at explainability, whereas the large language models aren't. How do you know they're correct or not? How do we know? Now, something like Go or chess, we know it's correct because we know the solutions work because they win the game, but not everything is as simple as that. I think your point is that there's a place for each of these, perhaps.
Yes, yes.
And then
yes,
the second part is maybe a combination of them can help make the large language models more understandable. And maybe, I don't know if they can help with the research, the resource intensive of the large language models. That's an ongoing issue. I don't know how we solve that one.
Yes, the only possibility there would be, for example, with these mathematical problems that one of the papers was talking about, the actual reasoning is done in symbolic AI, whereas large language models just extract the pieces of information. Whereas some systems try to use large language models even for that reasoning, but it's not really reasoning because there's no meaning behind. So using symbolic AI for that middle part of reasoning at least takes away some of the need of resources.
Okay.
Yeah.
Someone asked, can AI be used stochastically to solve AI's resource intensiveness? Well, I mean, clearly you can't use large language models to solve that, but can symbolic AI solve that?
I'm not sure. I think this is more of a cultural or societal issue, the resource intensiveness, because symbolic AI if you give us more resources, more CPUs, GPUs, we could also take advantage of that and solve bigger combinatorial explosion problems and so on. So it's more of a mindset that comes especially from the people in the tech world, the CEOs and those that actually have control, because nowadays the newest technologies are really developed by the big companies. You need the GPUs, which are so expensive. So universities produce work, but the big advancements come from companies. And it's more about whether those companies and the society as a whole pays attention to resource intensiveness. Is that something that we all try to work towards? And I think in the machine learning community, nowadays there is focus. I've also in the news, I see more information about power intensive systems, about water consumption more than 2 years ago. Although people have raised the alarm earlier, now there's more talk about it. So it's more about what we as humans do. We create these systems. Do we pay attention to it?
You know, we're kind of brushing up on one of the topics that's of interest to me, which is this idea of the singularity. In fact, I taught a course about that. The issue is, and you kind of talked about the techno-optimism. Can computers solve all of our problems? The resource-intensive use is a problem. Can computers solve that problem? Interesting question. And you know, the problem is that the computer usage to solve the problem is itself a problem. So maybe it takes some human in the loop to come up with some extremely different way of looking at things, or maybe, you know, in the future some large language model can do that. We're not there yet, though, that's for sure. Someone has asked, this actually has to do more with large language models, but I think it's important to think about. This says, when data is taken from social media, is it distinguishing between posts that are written by humans and those that are generated by bots? And do posts that are amplified by bots have a larger impact on AI simply by the fact that they're repeated millions of times? This is a large language model issue.
Yes. So I'll try to answer it, but I'm not an expert in machine learning, really. I have read an article actually talking about this idea that later models will take as an input human-generated data, but also AI-generated data, even in terms of images too, right? Those systems that produce images, and that the idea that it could create, in a simulation at least, that created to the generation of the models, because it's kind of inbreeding, right? So you have the output of AI becoming input for another AI. So I think there are issues there also. Which data becomes more representative? It kind of washes down. So large language models have this general model that is coming from everything that's written on the internet. I think the outlier voices will be less represented in the future in the input of AI. But again, I'm not an expert, and there are some guardrails that I know some of the companies are placing. Some of the information is also proprietary, so we probably don't know everything.
Yeah, and it's one of those issues that I know the early models probably didn't think about those kind of things, and it would be easy to game the model. And I think there are a lot of smart people working on these, and so I'm sure that later versions, they will think of that. Have they solved the problem? I don't know, but I'm sure lots of people are. It's a good point. And there's kind of a general question here about workforce challenges surrounding AI, both in terms of workers needed to ensure it's functioning at a high level, as well as job displacement. And of course, we looked at the symbolic AI that you were working with there. I mean, that's not ready for the the normal user to do. It still takes experts, and someone has to train those. Now, maybe in the future it'll be different, but what do you say about both sides? The training aspects, providing the experts, and then displacement of jobs.
Yeah, personally, yes, I think there will be some kind of displacement. So if we look at computer science, there may be some of that, but I think you still need the humans. Again, that idea of human in the loop, even coming from the creators of ChatGPT, it means that they know what they know, right? So the human has to be there. So we still need to train students in computer science and so on. It seems like prompt engineering will be important, just like we learned how to write our Google searches to get the information we want. It seems like there will be a little bit of that. Yes, I still want to kind of focus on this social aspect and human aspect. I personally wouldn't like to always have to interact with chatbots and so on. So I hope there's not a complete transition towards AI. And even large language models, they are based on language, but language exists because of humans. Just machines between themselves, they would not need language to communicate. So kind of think about what makes us humans and keep a little bit of that into the picture.
Yeah,
the need for social contact.
What you're emphasizing here, that large language model, I think there's maybe a feeling, a large language model, that's something computer scientists talk about, or these researchers talk. The language we're talking about there is human language. It's our language that humans produce that's being mined to produce these. So, it comes back to the human and the human's language. But I think I know you're interested in justice of many forms, and the resulting displacement of workers is a problem. But that's been a problem for technology for a long time. Not to say it's not important.
It's probably it's just the rate, right? It's happening faster. I guess we have to adjust to changes faster.
Yes.
Yes.
Molly, I think we've gone over time.
It's okay. There's a lot to know and understand here. A lot of little bits of information being considered. This is actually really fascinating stuff. I think that a lot of us are, while getting to know what AI can do, knowing how AI does what it does and sources what it the information it has is really interesting. So thank you for sharing this with us and helping us piece together, the layman's of us in the audience, sort of piece together how this works and why it works, and sort of what the challenging pieces of this are. And thank goodness there are good people like you two out there sort of working to refine and make sure that this is all safe and has utility for everyone. So thank you very much for that. We, on behalf of us all, appreciate that. Thank you again for sharing all of this knowledge with us. I know it's a pretty complex topic, but thank you for boiling it down so that we could understand. If you are interested in rewatching a recording of this webinar, or if you would like to share it with your networks, please feel free to visit our website later today at alumlc.org/MiamiOH, where you can find this recorded version. Thank you to Daniela and to Jim for joining us today. And thank you all at home for joining us. Love and honor to you, and have a great afternoon.
Thank you.